My name is Aaron Wiegel, and I'm a data engineer who has worked at a couple of different biotech startups. And I'm going to talk a little bit today about how trying to ingest data, which has like an unstable schema, so data where you're constantly getting new and different attributes all the time, can like sort of make this sort of a complex process, and how to simplify that with some clever tricks and a few different things. So just some context. A lot of times when working in a biotech company, we receive measurements from like third-party vendors. And a lot of these vendors specialize in doing lab measurements, not writing great software. So a lot of times the way you get data isn't through an API or anything, it's through like CSV files. So like they be like emailed CS files, put on someone's SharePoint, you name it. So kind of what we're gonna go through today is like how we could start with like a clean, simple file, and then sort of build in complexity in how that data gets ingested. And watch how our like bronze layer or ingestion layer turns into a bunch of spaghetti once we introduce that complexity, and then show a better way of dealing with that. So for those of you that aren't familiar, there is a architecture that was sort of popularized by Databricks, where you basically consider like 3 different layers of data. It sort of goes from a bronze to a silver to a gold, kind of like medals in the Olympics. So like that's why it's called the medallion architecture. So what you do is you basically take files from like an application database, a CSV, an image, and the bronze layer is meant to be like a raw ingestion layer where you have like minimally transformed data. Then you kind of take that data and further refine it, augment it, apply transformations, and make it more usable for things like business intelligence software, data science, AI, whatever. So the idea is that as you go through the layers, the data quality and usability of the data goes up. This isn't necessarily totally a new idea. Databricks just came up with a clever metaphor to sort of rebrand it. And it's something you don't have to do in Databricks. I know I'm showing a Databricks notebook here. I don't work for Databricks. You can do this in Snowflake. You can do whatever database you want. But if any of you in the audience happen to work for Databricks, I do take kickbacks in the form of swag. So we're going to focus just on the bronze layer today. So we're just going to focus on that ingestion part and not necessarily the other steps in here. And kind of show how that can actually be somewhat complex. You might think it starts simple, but we'll start simple, but then we'll kind of show how that can be really problematic, especially dealing with the kind of situation I mentioned that you often see in a biotech company. So, we have a beginning. We have a clean vendor file. Let's just load it into bronze. So here we have like some very simple Python or code in this Databricks notebook that basically is taking this CSV file, it's loading it into a Spark data frame, and it kind of just showing it here. And you can kind of see that it's just, there's some metadata there, like the sample barcode, some of the dates, and then some measurements. That seems pretty simple, right? So let's just load it into the bronze layer in a table, sure. So you could write that using this Spark code here, and sure, we've created a table. It has these columns. Yeah, that's why we have a whole half an hour talk about this. Let's go get a beer, right? But then the reality of how this actually works in the real world hits pretty hard. So what happens when we have different column names? So sometimes we'll often work with multiple vendors or doing similar measurements for different reasons, and we'll get the same data back, which is technically still like copper, pH, whatever, but it has different names for the columns. So just to show an example here, it's like kind of see those 2 different column names. We have, oh, sure, we have pH is now acidity, copper, ppm is now total copper, and zinc is now zinc total. Well, okay, yes, well, we need to standardize this somehow, so let's just go with vendor A as a standard. So we'll just add a column mapping. So here we just have some Spark code that's just doing a select on that column B, or vendor B columns, and just renaming them to pH, copper, ppm, so on. Oh, now they match. All right, well, that wasn't so bad. Maybe we should just go get a beer. But it kind of gets a little more complicated than that. So wait, vendor A sent different set of columns this time? So depending on what analysis, say, a scientist orders, they might actually do additional measurements in addition to your like standard basic set of measurements. So you actually see that some of these files might actually have a lot more columns in them. So just here to show an example where our basic package has pH, copper, and zinc in it, but then we have a full package that includes all these other measurements, like my favorite element, molybdenum. Say that 5 times fast. And you guys see that, okay, now we have all these other columns we have to worry about. What do we do then? And then it gets a little hairy. So we can create like a schema that has the superset of all those columns. And then you kind of see here where we're kind of just, I don't take the time to read that too much, but basically taking the big set of columns, making that the column header for all of our data, and then sort of aligning that schema to each of the different data frames we're getting. So you kind of see that when you do that, here in this data right here, they have a lot of nulls everywhere because sometimes you don't get those measurements. And now we have to and this becomes more complex as you introduce more analysis packages from different vendors over time. So the schema is just going to keep growing as new analytes are added. A lot of those analytes are going to be sparse most of the time or null most of the time because you're not necessarily doing that measurement every time. We need to have some kind of master list of all possible columns everywhere. And then what are we going to do when we have a vendor with a new analyte? We have to, a lot of times we have to change our code. And it can't tell what necessary columns are supposed to be null versus stuff that's just missing data. So it gets a little crazy really quickly. And then there's also all sorts of other issues that crop up because it turns out that a lot of these CSV files are hand edited. So that gets real fun, real fast. So, there's typos in the headers. So received, I know I can't spell that word, so neither can some of our vendors. So you see issues here where this column this CSV reloaded has all sorts of spelling errors in it, like sample barcode without an E. Received where it's I before E except after C. My favorite one I think I saw once was laboratory LAMPL ID. What is a LAMPL ID? So you kind of see you have to do something where it's because it's text, basically free-form text, we have to have some kind of might have to do some logic to convert all of those texts that we're getting from our vendors into the right spelling of the word so it aligns with all our previous schema. So then we have to have this deliberately really ugly code to kind of take each of those typos and fix them manually. So that's going to be fun to test, right? Oh, look, we fixed it. I hope new typos don't come in that we have to fix later. Yeah, so then it gets even more fun because, in Excel, you can kind of go in and, if you tap into press enter over on the side where the data is, you'll actually, when you save it, it'll actually do this weird thing, if you look at this raw data, where you kind of see if I loaded the CSV without using Spark, you see how there's all these columns on the right there that are filled in with blank, empty values, and then there's a header that they put in with, we need to contact this person, then the actual real data starts. So then you have all this other missing information in here. So we have metadata rows at the top. This example's a little bad. Usually the columns are below that, but don't worry about that. And then the real data actually starts around line 3 or 4. So then you have this weird file. The actual data is buried somewhere in the middle. There's all this weird white space on the side. And if you try to load that into Spark, or Pandas for that matter, you're going to get this kind of weird thing where you kind of see it adds a bunch of extra columns here, like underscore C7, C8, C9. And these are all null, and then there's weird metadata that's getting pulled in. So you kind of see this kind of natural human error that occurs where someone just put their cursor over there and pressed enter and didn't really think about it. Creates a nightmare for the data you're receiving from these vendors. So now we need to detect where the real header is and move empty columns, and this is clearly getting really complicated, right? I mean, this doesn't even really work, but you kind of see how this sort of header detection is needed. We need to remove empty columns. Yeah, and this is just clearly getting way out of hand, right? So we reduced our column count, but this is getting really hacky and brittle, and what happens when someone does something else completely different, and so on. So let's see how much time I have. All right, yeah, there's other things where sometimes put people invalid or annoying database characters. So someone put a pound sign or a % symbol in the column name. Now I have to type tick marks every time I want to write a SQL query. That's really annoying. So let's see what happens there. We kind of see there's a pound symbol next to lab ID. Sometimes people are using hyphens. This happens, and then you have to sort of take that data and sort of clean it up. These aren't invalid. In some databases, they might actually be invalid characters where the database won't even accept it. Databricks does, which I found out making this presentation. It's oh, fun. But anyway, so you kind of see now we have all these weird column names, and now we have to have character sanitation. So we want to strip out non-standard characters and replace them with something else. So now we have an additional thing we need to add here where we replace percentage with text represents that, or hyphens with underscores. And now we could fix our columns that way. So anyway, there's even more kinds of crazy stuff that tends to happen, but like, so the thing I want to ask here though is like, if we're trying to load our raw data and minimally transform it, is this really bronze data anymore? Or is this like, seems like something that would actually be validated in the silver layer, right? Because now we've done all of these transformations, and we look at like, say like an example of what this looks like. You guys see we have to run all these functions just to load the data, right? Like, is this really, truly the raw data? Like, at this point, this creates a point of failure, so if there's a problem, a new weird error crops up, then data's not even getting loaded, and you don't even have any observability about what the issue with the data is. You have to go back and investigate the files individually. Like, you know, we're applying a bunch of transformations. There's what happens when another vendor needs to be onboarded? Well, then we need to have another column mapping function. We need to add in more branches. You know, there's probably some quirk that they have with their data, and then you have to sort of figure that out. And then testing all this, since you've written all these sort of brittle specific functions that are vendor specific, you need like test, lots of stuff that creates your test suite kind of explode. And then integration testing. And then there's like, it could go on and on, right? So maybe there's an alternative solution here, because we just started with trying to just load the data. We ended up with all of these vendor-specific business logic, fragile string matching, complex conditional flows, and if someone finally gets it right and you want to modify it, that's kind of scary. So maybe there's a better way to do this. So maybe to go back to the title, the Zen of the bronze layer, not stealing from the Zen of Python at all. So what if we just let ourselves just accept the fact that there's all this chaos in these files? Like, one of the things that kind of maybe some people notice that these columns really aren't table columns. They're almost themselves data, right? It's like free text data that someone's entering. So the wide CSV that we're seeing from these vendors isn't actually the raw format of the data. It's like the individual measurements that represent the raw data. So let's create a parser for this data. So this is somewhat simplified for the sake of this presentation, but we're actually gonna go back to basics and use the CSV module in Python, because Spark and Pandas tend to introduce a lot of stuff that maybe we want to avoid in this case. They're great packages otherwise. Please almost always use them. But in this case, we're gonna load this CSV in a really dumb way and just say, open this file and convert all the empty strings to nulls. Basically it. There's some code here to remove any additional header space between the actual data and the those additional metadata columns you see, removing some of the white space, and then we're actually going to unpivot or melt the data into long format. So I'm gonna kind of skip down there. So kind of what we're doing is taking this wide data and then just taking the row index and the column index and just putting it outside and keeping track of each where the individual rows are, the columns, the attribute that the person wrote in there, and then the value. So we can deal with a lot of sort of quirks that come up in a more flexible way, right? So this will apply to any vendor. I mean, I'm sure there's probably other quirks that people could think of. Surprise the human ingenuity in coming up with some of these things. But now we can actually take this wide format data, remove some of the extra white space, stuff like that. So we're gonna start with that crazy file I sort of showed, and make each of the measurements their own row. So you kind of see that that's just a helper function to deal with Databricks stuff. But basically, we take our CSV file, we turn it into a list of records, and then just create a data frame from that, and we actually see something that kind of looks like this, where we just basically have taken our column index, row index, and shown what each of the different lab-provided attributes are and what their values are at that point. So in this case, before we had to go and handle all the different typos, potential casing issues, white space, metadata rows, empty columns, and had to do a different schema for each vendor, and there's sort of a complex transformation logic. Now we just taken it so each measurement is one row. We have the same schema no matter what the vendor is. the column names are preserved as is, even with the typos. And we can sort of deal with this sort of chaos by just like, let's just load it so we can deal with the chaos later, which is kind of the whole idea behind having this sort of raw ingestion layer. So the thing you need to add to this, though, is you need some kind of way to map those columns to more standard column names, right? And then that actually ends up being a good thing, because then we can actually enrich the raw data with a lot of information in the silver layer about what is this analyte, how is it normally measured, like what's the measurement method, like what are valid ranges for that data, and stuff like that. So you kind of see that in action here, where I just kind of loaded these tables I kind of made up. But you guys see that we have our vendor ID. It's the column name that it typically uses. And then this connects to an ID for an analyte that we can actually keep a standardized name for. So you kind of see that down here, where we can have standardized names for all these analytes, what units they're typically in, what data type they are, and then maybe some validation parameters that we can use for cleaning or monitoring data later, like minimum valid values, and then maybe some description to sort of fill out the details for someone who maybe isn't familiar with what that information is. So instead of doing all these complex transformations that are potentially brittle, all we really need to do is actually just join. So in this case, you guys see this data right here. We just take our unpivoted data, we join it to the mapping table, and then we join the mapping table to the analyte table. And we can actually get a bunch of additional information about those analytes, and this is much simpler than all the crazy complex transformations we had to do before. So you kind of see that what this kind of looks like here. We just have our lab provided attribute, the values that it is at that particular row and column, and then we can add additional information about what data type it is, the units, things like that. And then this works with a different vendor. So we could take a similar file, do a very similar join that we did before. And you guys see, you get something similar where, even though the analytes are different and the names are different, we have the same transformation we can use on both sets of data without having to have specific code for each. So we go back to the approach we used in the beginning. We had several different transformation functions. There was specific logic for each vendor. There's fragile string matching, and so on and so forth. When we want to add a new vendor, we have to have a new mapping function. We need to potentially make the control flow more complicated and make sure tests everything still works and deploy the changes. With this new approach, we just have one unpivot transformation. We do 2 joins to a mapping table. There's no vendor-specific code, and then that casing white space stuff we can sort of handle, maybe not automatically, but we can deal with it down the line. And if we need to add a new vendor, we just need new rows to the mapping table. So this is data and not code. So you don't necessarily need to change the code, and you don't necessarily need to redeploy things. You should probably still verify that it works by writing some integration tests, but you could actually have that task handled by a non-developer. And that actually helps, because in a lot of these cases, I'm not necessarily an expert on what the scientists are doing. They are, and they could actually probably better interpret whatever weird typos are coming up anyway. So if we wanted to load this data to bronze, this doesn't actually execute, but you could actually just see, we just load this parser, take our file path, and then just add new data to it. It's the same no matter which vendor we're using. So at some level, this pivoting is kind of a transformation. I think it's, you could even say that going from CSV to a Parquet file is also a transformation. So we don't need to be too literal about that. But we're not necessarily applying business logic. So a lot of the standardization or cleaning happens later in the silver layer. We're just deferring the cleaning. We're not necessarily stopping it. We can preserve the exact column names, typos, and all. So one thing to think about too is that because we have all the weird typos, we can also evaluate vendors. This vendor keeps sending us weird garbage files. Maybe we don't want to use them anymore. We could reconstruct the original if we want, and we're not necessarily making assumptions about the data. So the idea here is it's just that wide data is actually how the data is transformed so humans can understand it, but the long format that represents each of the individual measurements is actually what the atomic unit of that is. So our silver layer also becomes somewhat simpler. This is kind of very just to fit on the screen, but we can do our join, and then like say we know it's a numeric value, so we can actually cast it to numeric type, and then it's not a string anymore. Just an example of how we can take this raw data and then like apply the transformations we might want later in the silver layer. And that's also a lot more simple than trying to deal with like 200 different attributes. Important thing to keep in mind here, this isn't a silver bullet. You normally don't want to do this. just to keep this in mind, you normally don't want to do it this way. So this is a really common pattern in scientific realms, but normally entity attribute value, as this is known, is an anti-pattern. So if you have a lovely, stable, well-defined schema, do not go this route, please. Especially if you need to like query this data, like wide format data is much easier for people to understand. And in fact, a lot of this data that I'm showing here, like in like real applications, not like toy presentation code, we often put it back in wide format so it's usable to like an analyst or a scientist. Yeah, and like it's basically a really just helpful way of dealing with the data in the bronze layer. And because like querying these tables, if you've ever dealt with an any attribute value table, it's like not fun. It is like the most gnarly SQL you probably ever see. You also kind of see that like it's converting everything to a string. So if there's really strong typing requirements from the beginning, you probably want to, you need it for, so you probably don't want to do it this way. But you can convert the types in silver, and you could also like that could be part of your validation of the data too. Like maybe someone put like text in the middle of a numeric field, and you could actually, hey, you have the raw data, you can kind of compare and see like, oh, there's a text problem here. So EA-based tables are generally slower than wide tables, depending on the database, of course, just because you have more rows to scan. Although in a columnar database, this may be a moot point. So when this does work well, is your scheme, like I showed, the schema is unstable. You have different columns all the time. There's new metadata or measurements that you're doing all this time, and this is extremely common in like scientific research. Like the scientists are something like, oh, we're going to do this measurement now. Can we update the database? And the software engineers grumble, this is going to take forever, blah, blah. But the kind of thing is like doing it this way, there's a reason why this is very common in scientific fields, is like it makes it easy to, if someone just wants to try a new measurement, to have that data be tracked still, because they don't need to like migrate the schema to something new or anything like that. They're dealing with some kind of like semi-structured data. You have problems with trust with your vendors. And so like you just really want to like land the data and then transform it back later into a format that you want. One nice thing about this too is, like I mentioned earlier, like the column mappings can be updated as data, so it's a lot less of an overhead to like add new attributes if something comes up. There's a lot of stuff I left out here for simplicity reasons. Like in a real implementation, you definitely want to track where the files are coming from. Like when it was ingested, other things that I just left out because it's a 30-minute presentation, not a depth code review. The one thing you have to be careful of here is like some of the columns actually aren't measurements, so like the metadata that is part of that data, like the sample barcode, you actually kind of have to pivot those back in order to make it useful, because like it's not really an attribute, it's actually like the identity of it. And some things about just like data quality flags. One of the nice things about this is it makes it easy to monitor the data, so you can actually see whether like how the schema is evolving over time, what types of typos are common. Maybe it's something you just bring up with the vendor, like, hey, you guys are always misspelling received. And like sort of like because you have a form of the raw data, it makes it a lot easier to do profiling, monitoring, and other things. There's also things like how do you reprocess a file? I mean, I left out how did the CSVs even get here in the first place? Like, so that's kind of it. So I just kind of maybe go over that a little bit. So a simple bronze layer layer can become really complex fast if you have sort of like, because each vendor kind of added weird quirks of transformation logic, and then our code became vendor specific and really fragile. And like sort of one thing is just like sometimes question assumption about what the raw data is. In this case, the raw data or the like is actually like the long format data is probably closer to what the raw information is than the actual CSV files you get. There's a lot of benefits to this approach, and maybe going back to the basics here and just even jumping to the CSV module sometimes. Like I said, pandas and PySpark are great, but sometimes they're can be really kind of annoying and opinionated about things that you don't want an opinion about. So sometimes just keeping the other options in your back pocket is always good. And with that, I have any questions, and if anyone's interested in contacting me or looking at the source code for this repo, I have the information here. There's a whole other thing in here where I actually randomly generated all of the weird files, which was a whole other rabbit hole of crazy. So if you're interested in that too, that's available at that GitHub repo. So I'll take any questions if anyone has any.
We have a question in the front. Right. Right here.
This is interesting. So this applies to a lot of the work I've done in the past. Would this philosophy or strategy work if you have to consume more arbitrary data sources like NoSQL databases, connection strings to SQL databases you don't know, like maybe TSVs, maybe JSON-L files, maybe JSON files with like nesting structures that are different between vendors? How would you deal with that sort of arbitrary inputs in your bronze layer?
Yeah, that's a good question. So like here, it's like very much like one of the things that I think makes this usable this way is that the data we're getting isn't necessarily very big. Like we're getting like files with like 100 rows max. So I think you could probably potentially use this approach if you have like a bunch of like documents from like a NoSQL database that need to be like, you're not really sure what the keys are, or they vary a lot. This could be a good approach. I don't know if you'd want to use like exactly the strategy I use here, but you might be able to, or exactly, but like there's probably a way of like changing it into like a long format could be a good intermediate step to sort of understand what the schema is and how it evolves over time or how it changes. So there could be a lot of ways of doing that depending on where you're getting the data from. So I think that it could be applicable in those kinds of situations. It also could just be a good way, like if you really don't know anything about the data, like it could be a good way of like, even if you don't solve it that way in production, like as you're profiling or understanding the data, it could be a good way of like doing like sort of your design or like trying to understand what the design should look like, even if it doesn't end up being stored that way long term.
One more question.
This is a super basic question, or maybe it's more terminology, but why wouldn't you just, for the bronze layer, just store the files like directly as is and then do the kinds of transformations you're talking about in the next?
Yeah, actually I'm doing that. So if you actually look at sort of what I sort of put together, I kind of glossed over that, but in the workspace itself that I created for this like presentation, there's a volume that just has all of the CSV data. So you would want to store the raw CSV files, but this would be like the next step you want to take before continuing to transform it, if that makes sense.
Any more questions? We have time for some more if anyone has a question. Well, thank you. Let's give them